Hello, everyone. Welcome to another series with TrueFoundry. And we welcome Stefan with us today. And before we introduce Stefan, I'll just tell a couple of lines about myself. So, as you know, my name is Nikunj Bajaj, co founder and CEO at TrueFoundry. And I come from a machine learning background myself, having worked in conversational AI at Facebook and having led machine learning recommender systems and personalization algorithm teams at a startup called Reflection, where we were catering the e-commerce industry. And Stefan here with us is a Silicon Valley veteran who is also a hands-on leader, having 15 years of experience solving data and machine learning problems at companies like StitchFix, Nextdoor, and LinkedIn. He's currently building a startup called DAGWorks and playing the CEO role there, and is like the newest member of the YC club. So DAGWorks is trying to simplify building machine learning ETLs using a company's own existing MLOps infrastructure. Thanks, Stefan, for building within the MLOps infrastructure of the company. Prior to DRAGWorks, Stefan led the model lifecycle team at StitchFix. Its mission was to streamline the model productionization process for over 100 plus data scientists and machine learning engineers within the team. And they were building and deploying tens of thousands of machine learning model and provide automated model deployments that adhere to some of the best practices in MLOps. He is also a regular conference speaker and has guest lectured in Stanford's machine learning system design course, and is also an author of a popular open source framework called Hamilton that I've personally got a chance to check out, and it's great. Stefan, welcome to the session today. Would love to have you add a couple of words to introduce yourself as well.
Sure. Yeah. Thanks, Nikunj. Yeah. Thanks for having me. Yeah. So hi, everyone. Yeah, Stefan, as Nikunj said, the CEO of DAGWorks, a YC-backed company. And in a couple of sentences of what we're trying to do, well, we're trying to simplify machine learning ETL management. And so if you've ever inherited a machine learning ETL and been horrified by it, or had machine learning ETLs fail silently due to upstream changes that you had no idea about, and you wish someone had told you, or maybe you had to migrate your ETL because a platform component changed and you were forced to kind of migrate, even though your ETL was working fine, right? Or even maybe you came across the situation where you had a hard time tracing the inputs to your models, sort of the features that your model kind of used, or even maybe you wanted to reuse someone else and it was really hard. Well, if you answered yes to any of that, we're trying to build a product for you. Because your machine learning needs will grow in complexity over time, but your maintenance and kind of ability to maintain those ETLs shouldn't. In terms of just a little more background, why am I working on this? So as Nikunj said, I worked for 6 years at StitchFix, where I previously led the model lifecycle team, and essentially we were trying to build self-service tooling for the kind of internal MLOps machine learning platform for 100 plus data scientists. And so part of my role and experience was I got to see a lot of ETLs being built and a lot of teams struggling, and I found what worked well and what didn't. And so hence starting this company called DAGWorks. But anyway, thanks, Nikunj. Let's continue.
Amazing. Thank you so much, Stefan. And the problem that you described, I think literally everyone who is listening to this session will be relating with it. From a fresh grad outside of college who's working on data pipelines to CDO of an enterprise, I think everyone has experienced this problem. So I'm really looking forward to trying out the product that you're building at DAGWorks as well. But why don't we get started with you telling us a little bit about what got you to machine learning? What got you here, basically? Just tell us a little bit about your story.
Yeah. So I came over, I guess I've been in Silicon Valley since 2007. I knew I wanted to do something with computers, and then that's kind of the computers and undergrad. And so prior to coming to Silicon Valley in 2007, I did my undergrad in New Zealand, computer science. Knowing that Silicon Valley was the mecca of where things happen, definitely wanted to kind of make my way out here. So that's where I found myself. Did Stanford for 2 years, did kind of AI specialization, and essentially through my career in Silicon Valley, went from kind of back end full stack kind of engineering, moving over towards more kind of machine learning recommendation, kind of how do you build products and enable people to kind of move and iterate. So at LinkedIn, I was building prototyping content-based recommendation products. Then for part of the time there, then I went to Nextdoor, where I built a first version of data warehouse and kind of email analytics tracking pipelines, how to be kind of data driven, prototyping some content based things, and then I went to an NLP for enterprise startup that kind of crashed and burned, which was a great learning in terms of how do you build machine learning and then try to get and then how do you sell the product to someone, or at least horizontal infrastructure for other people to be successful with machine learning. And then at StitchFix, I chose them just because they had a large team of data scientists, so a very you could say interdisciplinary and set of modeling backgrounds. I guess through my career, rather than becoming a data scientist, I dabbled in that. I realized I actually kind of like building the tooling and making other people more productive with machine learning. And so, in which case, I joined StitchFix in a platform engineering role, where essentially, my task was to streamline the model development for data scientists, and which I got many years to kind of to do that, and built many iterations of platform tools for that.
Lovely. Awesome. Thanks a lot, Stefan, for sharing that background with us. You talked about leading the platform engineering at StitchFix, right? It would be very helpful for us to understand a little bit more in detail about how were teams organized within StitchFix, who were building out these models, what was their association with the platform engineering team. If you can describe us that setup, because I think that team organization is very interesting for a lot of our listeners.
Yeah. I mean, I want to say, so things are a little different now since I'm not at StitchFix anymore. So this is definitely what it was when I was there. But if you ever, you could say, interested, you should look up the multi-threaded blog on StitchFix, and it's a great blog, has multiple years of content there, and it will, if you're really interested in kind of diving into deeper in some of what I say, there's a bunch of blog posts there that you can kind of find in terms of how StitchFix was structured. But at a high level, StitchFix was it was a clothing company, and essentially they had what's called the algorithms org. So you can think of it, a team of data scientists, which were essentially given, kind of free reign, or almost at the beginning, they were actually given the keys to AWS, where their expectation was to kind of, build things to help other people in the business to make better decisions. So if you're selling clothes, what's a better decision? How much inventory should you buy? Well, you could probably forecast that, and because clothing is a margins game. So if you can figure out better efficiencies in terms of how the business operates, the business can kind of run better. Classically at StitchFix, we were trying to recommend clothes to people, so we had a whole kind of team and suite of people who kind of were on that. I guess so moving back in terms of how things are structured. So there was an algorithms org, a bunch of data scientists. They were organized into verticals, helping different parts of the business. And then there was a horizontal team called Data Platform, which I was part of. And so we were trying to slowly chip away and build, abstractions and tooling such that the data scientists didn't have to engineer quite as much to get their jobs done. So StitchFix generally hired people for, what was termed, full stack data science. So trying to get people who could do, prototype, productionize, and then be on call for things. And so that meant being able to stitch together whatever engineering requirements were to get something up and running, but then also being able to do the modeling and kind of the explanation and the product management side of building something and plugging it back into the business and providing value. The platform team itself was kind of organized into other components. So you can think of it as a team that was in charge of, say, the Spark, Presto clusters, Kafka infrastructure, the orchestration system, the environment. There's a team on kind of the recommendation stack and microservice deployment. And so and then A/B testing and experimentation. So I started kind of 3 teams there at StitchFix. With the last team that I kind of spent the majority of my time was building out the model lifecycle team. So trying to streamline and kind of connect together all the different streamline the experience of data scientists, connecting together all the different kind of platform subcomponents. So how do you go from training to model deployment and make that really easy and seamless?
Nice, the big beast in machine learning. I have a couple of follow-up questions here. So talking about the horizontal platform team, right? You mentioned about a lot of operationalization elements that the team was working on, data platform kind of thing that the team was working on. There's a new trend that I'm seeing that some of the horizontal teams also start to take up the more fundamental models being built within the company, right? So for example, like you train an embedding model and become like a central layer for embedding,
Yep.
Right? So did you also cover some of that scope in the platform team, or was there any discussions around that?
Yeah. I mean, so that was actually, that was debated a little bit. It's like, how do you, how do you structure those teams? Where should they live? Should they be on a platform, or should they be a horizontal kind of data science team?
Yeah.
Some of them, I think, for me, I think the conversations generally where it went was how much business context do you need to be able to run successfully, and so in which case what StitchFix kind of ended up doing was building that horizontal team, but generally it was that model wasn't necessarily generally broadly applicable to all teams, so it was generally confined to a business vertical. So say all the client recommendations. Anyone who's doing client recommendations probably wants the embedding model that relates to clients, and so there would be a horizontal team kind of created within that. But they were data scientists, but then they had to work closely with us in some instances, just because some of those horizontal models obviously get more data and we're scaling a bit more. So we kind of partnered with them appropriately to kind of try to build the tools and infrastructure to kind of enable them to own things. But essentially, if you owned a horizontal model, you're still in data science, not platform, but you were treated, your end user customers were other data science teams, so it was kind of platform-like.
Got it. Understood. Okay. And then a couple of other things around here. You mentioned about the data scientists building out the models, the algorithms team building out the models, and then the platform team maintaining them, right? What was the...
No, sorry, just a correction. So the data scientists were responsible for owning and owning the models and owning the results.
Okay.
Platform team, if you bought into our platform infrastructure, we ensured that Airflow ran, that Spark was up. My team specifically, we're trying to actually build tooling and infrastructure such that you didn't have to worry about the deployment infrastructure for your model. We would guarantee we could deploy your model and we would take care of it. But you were still on call for the model because we wouldn't be able to know how to debug it. But we would ensure that a good model could be deployed, since we could kind of build that infrastructure and ensure that.
Got it. Okay, understood. So there was no quote unquote handoff of the model that happened between the algorithm team and the platform team, basically.
Correct. No handoff. That was StitchFix from the beginning was very much how do we avoid handoff? And therefore, part of the thesis is that if you can avoid handoff, the person who's building the model can move faster, can make better decisions, can make better trade-offs, just because they have full context of if this feature is really expensive to add, but it doesn't actually add that much to the model, then maybe just skip it. Whereas if in a handoff model and you're just given things and you don't know how expensive something is to implement, right, you can potentially make suboptimal decisions. But yeah, StitchFix's whole thesis, I think, it was which I think I buy into, is that if the data practitioner or the person who's building things can do things and move things end to end, then you can just get many more iterations in with the model, and in which case that's generally how you outcompete someone is by out iterating them.
Nice. Awesome. Okay, great. And the last question as a follow-up here is, how was the infrastructure allocation handled? So for example, if a data scientist needs certain number of GPU machines, certain number of whatever Spark cluster that they want to run things on, can they request things by themselves on some UI, or they will have to come to the platform team? How was that getting handled overall?
Yeah, I think so. Platform generally owned the quotas of what was available, and so. But in general, we tried to ensure that we assumed everyone were good actors and had good intentions, and so in which case it was generally pretty easy to get whatever nodes or whatever was required. There was obviously some accounting at some point, hey, why is this team spinning up so many jobs or requesting that much? And so in which case, there were people who were keeping tabs on kind of cost, and then kind of checking in with teams to double check, is this really worth the money and stuff. But otherwise, in general, with platform, we tried to enable people to get what they wanted easily, without kind of getting in too much of the way. But we did. There were teams that basically owned the quotas and ensured that at least costs didn't spiral out without good justification.
Understood. Awesome. Thank you so much, Stefan, for clarifying that. The other thing that I would love to learn about is, in this entire platform engineering team building journey, what were a couple of innovations that you remember that your team made that kind of stands out to you? What do you remember the most that, this solution was extremely neat that we came up with?
I mean, I guess I'm a bit biased. So
Whatever is shareable, by the way, whatever is shareable.
no. Yeah. So everything I've either presented on or there are blog posts on multi-threaded if you want to dive into and know more. I guess three things kind of come to mind. So one is we built what we termed the model envelope. The analogy was an envelope's a container, and so we wanted people to be able to package up their model and anything else they wanted to shove into the envelope and then just ship it and have it sent somewhere. And so we basically, similar. We grew up at this, started the project about the same time Metaflow was kicking off. So we, took some ideas from them and took some ideas from TFX and a few others. And so essentially, it was a system where an API, a data scientist, anything that was written in Python, given the API we gave them, they could save it. We would capture a lot of things, and then with one button and some extra metadata and configuration, say like what the name of the service, they could have that model deployed in production in easily in under an hour. I think very similar to the stuff that you've built, Nikunj. And then, but the envelope also enabled people not only to create microservices with their model very easily, but also it came with a batch job as well, so they didn't have to write a task they wouldn't have to know how to write a task to make it their model run in a distributed fashion on Spark. We kind of took care of that. So model envelope was one of those things, and so it kind of enabled people to store metrics, but then so with the envelope analogy and things about the model, but then also enabled you to kind of ship and kind of send your model for use in various places. Number two was, I think, a configuration-driven approach to describing machine learning ETLs. There are kind of, so essentially you can kind of think of, we got data scientists to describe the ETL basically using YAML, coupled with Ginger, which describes, say, SQL, and then Python code to describe kind of model fitting. So the idea was, can we abstract the orchestration system from underneath the data scientist such that my team could come in and kind of swap different parts out of the Docker container that the model would train on, because we haven't leaked too much into things. So we have a blog post there if you're interested. And then the third thing was Hamilton, which is one of the things that my team open sourced, which is a declarative micro framework for describing data flows. Essentially what that means is there was a team struggling with kind of feature engineering, especially they were doing some time series forecasting, and time series forecasting is very easy to create thousands of features very easily. But they were struggling with kind of the code base and how to kind of manage and maintain it. And so Hamilton, we came up with Hamilton to help them structure the problem. It's analogous to DBT in a way, in that DBT helps people structure their SQL in this kind of testing documentation friendly manner that gives you some semblance of lineage. Hamilton's very similar, but for Python transforms. And so it's very amenable to kind of describing a transformation process without having to manage Python scripts. You write functions that declare a data flow, and then it's very easy to kind of share those definitions, have things run in offline and online context pretty easily. So that's open source. If you Google StitchFix Hamilton, you'll find it. But yeah, those are three things. Happy to dive in more. I realize that we probably have a lot of content to talk about. But yeah, what do you want more details or descriptions on?
For sure, yeah, I would love to. So I think the part of the model envelope is fairly clear. Personally, I've played around with Hamilton, so I also understand that. The part where you talked about replacing certain parts from the Docker containers, right, as a platform team, that's a part that I did not understand very well, and would be great if you can dive deeper into that.
Yeah. So part of you could say one of the golden, well, I termed it a golden API. So to my team, I was like, hey, how can we describe or build an API such that a data scientist can describe what they want to happen, but then us on platform, we have enough flexibility such that we can actually change things without requiring a migration, or without forcing a data scientist team to really come in and say, hey, we've upgraded some library, you all need to go upgrade it. So can we somehow do things on the back end, because we've kind of abstracted out, some of those things for them. So with our configuration driven kind of model pipelines, part of the idea was that the data scientists, when they were building their model, they just provided a requirements.txt, and that just only contained their subset of changes. What they didn't describe was the platform dependencies that they depended on, and that was kind of taken through our system. And what that meant was, if we wanted to change something and wanted everyone to upgrade, well, it was pretty easy for us to do that and kind of redeploy people's ETLs without them kind of having to do it, or having to kind of update or upgrade their Docker containers, since that was information they didn't have hard coded within their ETLs, and it was something that kind of a degree of freedom that we controlled and not them. And so that was just one use case. Was sometimes you want to upgrade the logs or some sort of meta information, but you don't want to you want it to be kind of picked up by everyone pretty easily. Sometimes if you do that naively and people embed your platform tooling, then they pin the versions, and then you have to go find real place of the pin, and it's just a nightmare to kind of migrate everyone. And so part of the idea was like, can we remove that need for the team to kind of manage it, and enable us to kind of more centrally manage it and kind of update things without people having to redeploy or rewrite their pipelines.
Interesting. Okay, I see. So here, when data scientists are building out these, let's say, containers, and they're kind of running it on a remote cluster or something, one of the problems that we hear in this context is the containers take too long to build, or the debugging on this remote development can take a lot of time, because like the container will take time to build and then deploy, and then logs will come in, etc., right? So did this approach of kind of like centralizing some parts of it also have an effect on the build and debugging time of it, or did you all solve that problem in any other way overall?
Yeah, I think we definitely could have done better there. I think from memory, in terms of the Docker containers, so we tried to give there was another platform team in charge of environments, so they tried to kind of standardize and provide kind of standard Docker containers that kind of came with some things, but invariably people always wanted to add their own kind of libraries and things. And so there was we tried to add caching to things. So if we saw the same requirements.txt, like, you wouldn't have to reinstall things. We just had that already. With Python, it's nice. You can, or at least for most Python libraries, or if you save the environment and zip it somewhere and then pull it back, you've kind of installed things. So they were kind of things to kind of speed up kind of creation of Docker containers. It's StitchFix in general. More often than not, Docker containers for each ETL were kind of rebuilt each time the ETL was ran, or at least the last layer of kind of libraries and things. And so we basically tried to cache that to really speed that up. But otherwise, we really try to encourage people to develop locally, or at least figure out ways that you don't have to wait for a full cycle of your Docker build, run my script, see if it worked, and then debug cycle. And so part of what my team was doing with this kind of configuration driven model building, model pipeline building, was to enable people to do things locally in a Python environment without building the Docker container. So at least, like, if they're working on a single step of their ETL, it was, we tried to make it run. We tried to enable the loop to run locally. So, pulling down some data, caching it for them, etc. So that's kind of, some of the usability stuff we're trying to build in to kind of speed up that loop. But yeah, I agree. It could be faster. I think there's people who are trying to actually, change Docker and rebuild that to make that problem, not as bad.
Are you talking about modal?
Yeah. I mean, or it's modal's one approach, I think.
Yeah. Lovely. Awesome. Thanks a lot, Stefan. So we talked about some of the innovations, right? And of course, like machine learning, MLOps in general have a lot of like standard challenges that probably we all of us understand. Was there something unique to StitchFix that you noticed, that the kind of problems like most companies outside are not facing, and then you experience some of that, you have to go solve a couple of those challenges?
Yeah, I mean, so I think it's just a lot of people doing a lot of different things. Like there are 100 plus data scientists. So if you think of each data scientist owns a model. Okay, how long? What's the average tenure? Like at least 2 years. How often what's the model development speed and iteration? Like there's essentially a lot of teams building a lot of models, and there wasn't necessarily big data challenges, but it was just there was a lot of jobs, a lot of people doing things, a lot of how do you enable ownership for a team, because individuals build models but teams own them, and so if you made it really easy to create models, then someone has to maintain all those ETLs. So if someone leaves, then some teams struggled, you could say. Yes. And so it was either throwing that code away, which was kind of wasteful, or being slowed down until they could figure out and understand what was there before them, right? So I want to say StitchFix is, you could say, the unique insight or challenges for me that StitchFix had was basically how do you deal with the scale of a lot of people, and then how do you deal with people building on top of models, since invariably that kind of happens because someone wants that. Embedding models are a classic case of this, where people want to build on top of other teams' models to use it as features, and so you kind of then your ETLs then have these kind of interdependencies between them and data, and so then you have to really think about features and versioning, and so those are one reason why I stayed so long at StitchFix was precisely because of those challenges and figuring out how to solve them.
Interesting. So Stefan, like these challenges that you're talking about, right? Like how do you manage large teams who are building out different models, potentially different types of data sets, right? Each working with their own libraries and frameworks, etc. There's like we know that there's a bunch of open source tooling that tries to solve parts of these problems, right? If not all of these problems. So was your approach to solving this problem trying to piece together a lot of like these external open source solutions, or did you all end up building primarily things in-house? What was your approach there?
Yeah. So I guess we primarily built most things. We only bought a few things, mainly because we just had so much heterogeneity, and we didn't want to constrain that in terms of like, you want to use Stan, you want to use PyTorch, you want to use TensorFlow. Actually, no one used TensorFlow, actually, funnily enough. Everyone preferred PyTorch, but like if you want scikit-learn, I don't know, stats models, whatever kind of modeling library you wanted, like if it was Python, we supported it, and that was partly just because the different teams have different problems, and different libraries and packages were potentially better suited to those types of things. And so I would have loved if we could have standardized, because that would have made some platforms' life easier. So for example, if everyone was just using PyTorch models or TensorFlow models, it's very easy just to just use that suite and ecosystem of tooling, and we wouldn't have to engineer too much, since there's a lot of open source stuff off the shelf, right? But in which case, we also started, StitchFix was around for a while, and machine learning was, core to the business from day one. And so there was a lot of, we had to build something because there was no solution or something that was kind of useful at the time. So for example, one reason why we built Model Envelope was because there was no, open source thing that kind of fit our needs, as well. Similarly with the the configuration-driven model pipelines. And then similarly with Hamilton, there was nothing there that could have, and so we built a lot of things. I want to say, most things ended up living, pretty decent lives from that perspective. So we didn't throw away too much effort. But I guess, where do you want to dive into, or at least I've kind of forgotten your question, so now I'm pausing.
That's okay. Don't worry about it. I think you got it. You got it already, Stefan. All right. So Stefan, I have two follow-up questions on what you just described, right? So the question number one here is, you talked about machine learning being integral to StitchFix from practically the day one of the company, right? Mm-hmm. Now, some applications of StitchFix, of machine learning at StitchFix, are fairly clear to even me as an external person, that the applications of recommender systems and are fairly obvious, right? Were there some other things that StitchFix was using machine learning for that it got some immense value out of it, but it's not as intuitive that this is another area where ML could have an impact?
I mean, I want to say if you broaden it to any type of modeling, I mean, one reason why we called ourselves my team the model lifecycle team rather than the ML team was because we didn't want to alienate anyone who didn't feel like they were doing machine learning. So, example, there are people doing Markov chain Monte Carlo simulations, time series forecasting. Let's see, linear logistic regression to your embedding recommendation stack stuff. So. Can you repeat the question?
So the idea was that, like, basically, is there like a separate type of, like, I guess, a different impact of machine learning that's not intuitive to an external user?
Yes.
Like recommender systems are very clear impact,
Sorry.
right?
Yeah. So, so StitchFix, there was a very broad swath of modeling. So in which case, there were people doing Markov chain Monte Carlo simulations, time series kind of analysis and forecasting, linear logistic regression, very simple stuff to the more complex stuff. And so if you think about a business that has warehouses, people have to pick clothes from bins to satisfy orders. There was a team who was actually optimizing, the routes through the warehouse. Like, what is the shortest path and distance to pick orders, right? And so that was, it made great internal visualizations and stuff, and I thought it was pretty key. Help. If you can speed up how people pick clothes, then you can save a cost and process many more orders, right? And so then when a buyer has to decide how many clothes to buy, they have to figure out the sizes because everyone comes in different sizes, and that depends on the population of who StitchFix is served. So then you got to tie in, but then the population that you serve is dependent on the kind of demand generated, say, from marketing to bring in signups, right? So you kind of had this forecasting cascade of things that then people used internally to help then simulate or forecast, and try to provide that human person a decision as to, well, okay, you want to buy that type of jeans? Well, here's a breakdown of sizes we think. Potentially, these ranges of size or these allocations between things, which we kind of depend on. And so for me, coming, not having worked in a company or a retail company such as StitchFix, it was pretty eye-opening in terms of just where you could apply it. And so I guess someone said to me, I guess one way they described what StitchFix did was they basically built their own internal enterprise resource planning system from a bunch of built by the algorithms team. Not necessarily entirely centralized, but in spirit, essentially that's kind of what StitchFix kind of built internally is how do you plan for inventory? How do you plan for the warehousing? How do you get people to optimize? Where should you ship things from? Different companies have different shipping rates, and so in which case there's also optimizations you can run there to determine the best place to send the clothes for you from. Nikunj, since everything for an order was sent from a particular warehouse, but maybe there were choices, right? So there's to me, that was StitchFix was amazing in that regard of just seeing how and where you could apply things outside of classic recommendation stuff.
Very, very interesting, very unique. So basically, one thing that I want to call out to the users here, that if somebody is looking for great startup ideas, turns out companies like StitchFix are building their own ERP systems, and maybe you wanna help these companies, by the way. Anyways, the second follow-up question that I had, Stefan, was we talked about tooling chain within StitchFix, right? Like, what were you using from the external tooling? What did you end up building out in-house, right? We get this question a lot from our users that now MLOps is clearly very inundated with a lot of tools across the entire life cycle of data management to model management to monitoring and stuff like that, right? So if you had to pick 1, 2, 3, 5, 10, whatever number of tools that you think is the minimum number of tools that allow people to still build out a fairly mature MLOps pipeline, what would those combinations look like according to you?
Yeah, good question. So I mean, I'm slightly biased, so I would say Hamilton should be in there. Mainly since you should have a way to kind of help structure your code, because I do think the longevity of your MLOps kind of or the ability for you to kind of deliver on MLOps really depends on how you write the model in the first place, because how you write the model is the scaffold that you can attach a lot of different MLOps kind of tools and best practices to. And so, which case, just having an opinionated and structured way in terms of how to build your ETLs. And so, I want to say Hamilton is one way that you could build on top of that to help structure the code.
Sure.
In terms of tooling, I want to say depending on your, it should really go back to business impact and SLAs. If you optimize for or just go with the thing that has the least amount of moving parts, and so which case don't bring in an orchestration system unless you really need the multitask aspect of things. If specifically saying, like, if you're building an individual model and everything fits in memory, just optimize for everything running on a single node. Don't try to optimize, prematurely optimize, right? And then, so once you have a structured Python script that you can kind of schedule and run, then if you think about from a first principles kind of perspective, data versioning and model kind of registries or model versioning are essentially just really abstractions around storing some data and then some extra metadata around it. And so you can get a long way just by saving things to S3 in a structured kind of path structure, right? And then storing the metadata with them. Obviously, once you get to more than one people in the team, that's where these kind of horizontal tools actually have a bit more. And so I don't have an opinion in terms of the whether you should use DVC or not, because I think that really depends on your domain and what you really need to version. But in terms of the model registry stuff, I think there's a lot of open source tools. So if you want to go the open source route, so MLflow will get you reasonably far. Else, if you want hosted and management solutions, and you have TrueFoundry, or Verta, so there's a lot of people on the stack. But I'm kind of long-winded answer because I do think there isn't a one-size-fits-all thing. But
sure.
at least from a first principles thing, I think it's like for me it's Python. If you choose, if your deployment SLA. And you're always going to be in a certain type of model, then maybe PyTorch and that ecosystem with Onyx is the way to go. Or if you really want to run on multiple devices or have your models, then TensorFlow and its ability to kind of compile to different things could be the better bet for you, but it requires a higher engineering cost. But one thing to note in your stack, you should have some sort of A/B testing kind of system, since machine learning, it's great, it's fun, but it should actually have serve a purpose and be measurable around some business kind of impact. And so I actually advise people to build in A/B testing, or the ability at least to measure the machine learning impacts against some business KPI first before thinking about model quality and data quality, because at a high level, if you can measure the impact of your model, that is first the closest, or at least it's not a model measure, but at least it gives you a good way to kind of understand the value that your model brings to the business. And then from there, start to work backwards and build in different model quality and MLOps practices. Since then, if if anything bad happens or any changes, you have the measurement to understand the impact of the business. So then you can also understand where you need investment and where you don't. Since if the cost of an error is small to you, then maybe data quality stuff doesn't matter, right? Hypothetically speaking, but the only way that is if you can actually understand the impact of machine learning or what the model has with respect to the business. So, long-winded answer. Definitely, probably not satisfactory for some. Sorry about that, but feel free to hit me on Twitter.
It's a very hard question. It's a very hard question, and I don't think there is one right answer, of course. So I love to keep getting this perspective from more and more experts like yourself, so that after a while, our listeners can build their own mental model that like this type of use cases, these type of tools are sufficient, this is an overkill and stuff like that. So thank you so much for answering that question. Stefan, we have talked a bunch about your experience at StitchFix, and I think one of the things that I'm also very curious to understand is what are you up to next? Like, what is DAGWorks? Like, what are you trying to build? Again, how much ever you can share. I don't know if you're keeping things under the covers now. So, yeah.
Yeah, so we're trying to build an open source ETL platform for data science teams. So open source being around kind of Hamilton. An open source platform for ETL team for data science teams, where we're essentially trying to reduce the reliance on engineering. So if we want to enable data practitioners who aren't, don't have the software engineering background to be able to write code that goes to production and own it. And we want that to kind of, we essentially want to help them manage the machine learning ETL artifact on their existing infrastructure. So we don't want to, we're not trying to compete with, say, with Airflow, for example. We want to kind of, because most of the complexity that we found with, people use data scientists can get Airflow up, but it's the code within the task that gets complex and has all the dependencies and kind of, dictates, what features should be used and, how to build the model, right? And so we want to help people kind of maintain and build those artifacts. One of the nice properties of Hamilton is that, your code is unit testable, documentation friendly, and you also get a semblance of lineage. And so coupled with that, we're trying to, I think we have an interesting proposition of a product where you can kind of get some cataloging out of the gate. And so a central feature definition store is really easy to build with Hamilton. The other is lineage. So it's very easy then to kind of, you logically describe the lineage or like the computational graph that should kind of happen. And so you can store that as an artifact with your model. And so if you ever want to know, okay, what data, or at least what were the features that were used to build this model? Not only if you store what the data source was, then you can also walk through the code to actually understand as well, kind of graphically, what the computation was. So we're trying to make the debugging aspect thing easier. Or the other side of it is you could potentially use it for compliance cases if you want to kind of have someone audit and verify this model was created with this code and these data sources. We're trying to I think we have a platform which we can make that really easy to answer on.
Got it. So would it be something like Hamilton would run on top of, let's say, an Airflow or an Argo pipeline or something?
Yeah. I mean, to me, data scientists shouldn't really care about the topology of where things run.
Sure.
Most of the data scientists that I know really enjoy the act of building, model iteration, building features, but figuring out the right way to write an Airflow task so it's easy to debug.
Right.
And is little yes, it's useful. Should they know it? But potentially. But I guess in my world, if it's not, that doesn't sound that valuable to the business for them to do it. And so, in which case, if we can provide abstractions where you can kind of write code with Hamilton, and then we can help connect it with those other tools, then we can save people time. But then the flip side is if those tools have to change, it's very easy then to regenerate the pipeline, for example. So if you want to upgrade, Airflow versions, it shouldn't be a stop the world and a huge migration.
Sure.
If we can generate the workflow, then we can also change it and update it very easily. And so then make the maintenance and kind of the platform aspects easier to maintain. And so I guess with MLOps, most people know that, it's very easy to get vendor lock-in. And so part of the idea is that, how can we also abstract some of the pieces such that it's easier to kind of change, data quality providers. So if you want to, it should be easy to go from, great expectations to, Y labs or something, right? Without,
Yes.
you having to rewrite things. And so we're trying to figure out ways and abstractions to kind of, make that a possibility.
Got it. Okay, understood. So, and that's what you mean to say by running it on top of your own MLOps infrastructure is this becomes an abstraction layer, and you could be using an Airflow or an Argo or practically any orchestration layer underneath, essentially.
Yeah, and you could be connecting it to, to TrueFoundry. Yeah.
Absolutely, why not? And one other thing here is, would this be very different from what Metaflow as a problem that they are trying to solve, or would this fall in a similar domain moving forward?
Yeah, I mean, I think so. Hamilton models the micro very well. So if you're coming just from the open source perspective, what we're building on top of, Hamilton models the micro really well. We actually have a co-blog post with them, Hamilton using for feature engineering and Metaflow for the macro workflow. I want to say, I don't believe Metaflow is trying to enable you to model the micro within a task, right? They're trying to still continue the macro, but then enabling you to deploy and run Metaflow on different kind of backends, right? I think part of the idea is if we compile code onto Metaflow, we can give people the same ability and benefits, right? And so really, I think we're trying to be pretty complementary with those tools. I don't see us replacing them. Since there's a lot of competition on the orchestration space. I don't necessarily want to throw my hat in the ring there, but I want to enable people to be more productive on top of those systems.
Lovely. Awesome. Well, thank you so much, Stefan, for sharing with us your wisdom in the MLOps space and also sharing with us what's the new cool stuff that you're building. Really appreciate you taking this time and participating in this episode with TrueFoundry. We look forward to staying in touch with you.